Hello everyone. In this video, as discussed in the introduction, we will start with the very basics of data warehousing. What do we really mean by data warehousing? Let's look at some background first. So to take a background, every organization will obviously retain all of their data, will store all of their data in so-called databases. This databases term has become really generic, and actually the term databases can either refer to a transactional database or it can refer to a warehouse. A warehouse which is used for analytics, which is used for reporting use cases. However, the most common case or the most common area where a database is known as a database is still a transactional database. An different way to look into the bifurcation of the databases in the current world can be said in the form of SQL databases or relational databases, which follows principles like ACID principles. And then there are NoSQL databases, which follow the base principles. Now, to make this interesting, to make this less tech jargon heavy, let's try and understand the ACID or the relational databases and the base or the NoSQL databases in a very simple language. In case of a relational database, an example can be SQL Server, an example can be Oracle, for example, right? We can see some of the properties that I have listed over here. At the first place, almost all of them have very strong consistency. Each and every record that we write in the databases are always written in the database. There is almost always no data loss until or unless something really goes bad. There is isolation. One transaction is not affected by another. The entire system or the architecture is almost always transaction driven. The system is almost always robust. The interaction with the system is almost always using SQL. The code itself is very simple and it is very easy to learn. And obviously, last but not the least, these databases are usually always available and always consistent, right? However, we have seen, basis our experiences, that they may have limited capabilities at times in scaling up. I'll mark this with an asterisk, since we need to take this with a pinch of salt, since there can be customized solution by corporations like Oracle or Microsoft, which can help reduce the limitations of RDBMS or relational databases scaling up. But these are specific products for which may have to buy additional licenses. The other common problem, although not always really a problem that we see, is that these relational databases are often always part of a shared infrastructure. They have a limited or a specific amount of disk, CPU and memory at any given point in time. Now let's look into the NoSQL databases, where we said that the principle that is followed is also known as base principle. Now, how do we understand what is base principle? In case of NoSQL databases, example given like MongoDB, or we can take examples like Cassandra, for example, right? We usually see weak consistency. This is not always the case, but we usually see weak consistency. Usually what happens is, whatever we have written in the database in tables or in form of records, etc., at the last or the latest is what is going to win. It is usually always managed by another program or an application. Usually an application that is written by a software developer or a team of software developers. Usually we don't access these databases using any query languages, but there are cases where we might need to if we are going to do any data analysis, if we are going to do any operational investigations, and so on and so forth. However, when we do that, we realize that the NoSQL databases are really very simple in structure. They tend to represent the real world. or the conversational world or the natural language world in a very relatable way. However, the code or the structure or the schema that we follow inside the database to store the data or to retrieve the data is quite complex. These databases are usually available and partition tolerant as well. They scale out usually in an unlimited way. They can be really well scaled out. They can be really scaled out in a very easy way. Last but not the least, nothing is shared, hence they can be massively parallelizable as well. Let's not confuse this term with the massively parallel processing DBs. That is a different concept. We are not talking about that over here. Now, keeping these concepts in mind, where does the data warehouse come into picture? Yeah? The data warehouse comes into picture for cases where we find obvious limitations with the transactional databases. Example given, the transactional systems are usually not optimized for a design for performing of large scale analytics by default. Why? Because in the transactional databases, in the transactional world, in the RDBMS world, in the ACID world, the databases inherently contain the notion of normalized tables. This results into joins. Hence, there is inefficiency at scale. This is the reason why, or because of this limitation, so-called, of traditional database systems, we come up with a new concept or come up with a so-called new concept which is not so new, also known as data warehouses. Data warehouses, by the definition or by the design, store variety of data sources, right? They can store variety of data sources, but their main intention to store the data is for analysis purposes. They are not to be confused with traditional transactional database systems which are used as the backend infrastructure for a banking system, for example. The variety of data sources are stored only for the analysis of the data. And last but not the least, the data warehouses contain inherent design principles. They are architected in a certain way that they can very easily and out of the box support operations at scale. Now, depending on what kind of data warehousing system we are developing or we are using, this statement might change. The inherent nature might change. The capabilities might change. The performance might change. But overall, this is what we expect from a data warehouse system. Last but not the least, there are a few additions to this world of databases, the world of NoSQL, SQL, and the data warehouses and so on, which are not so new additions as well. For example, there is one terminology known as a data mart. We can say that these are children. These are children of a data warehouse because they are a very, very specific part of a data warehouse. In other words, or in a very simple word, if I am designing a specific data warehouse for a specific department in my organization, for example, the HR department or the finance department, that is what I am going to refer as a data mart. Obviously, when we do a deep dive inside BigQuery, its internals and its working as part of this series, we will come to know more about how data marts really look like or how they are actuated using systems like BigQuery. The other concept that we need to be aware of, the other terminology that we need to be aware of is called data lake. A data lake can also be called or can also be remembered as a dump yard. It is basically a dump yard where, or the reason why I call it a dump yard is because this is where we will store all of our raw data. So, whatever data we are generating as part of an organization or as part of a group is to be directly stored without any transformation, without any changes, without any cleaning inside a data lake, so that it is part of a lake or a dump yard as long as we don't identify its purpose and then we start warehousing it or then we start to clean and massage it, and then we start to store it somewhere else in a structured format maybe, and then we can think of use cases like reporting and analytics, right? So overall what we have seen in this video is that every organization, when we are storing any organization's data in form of databases, the databases can either be transactional. This is by and large the majority. We can still say this is by and large the majority as of date where the data is stored. These are systems which is going to power backends of banks and transactional systems. And then there will be warehouses. Warehouses will be used for analytics. Warehouses will be used for reporting use cases, right? On the other side, or in a different terminology, the databases will either be called a SQL or a relational database, or it can also be called a NoSQL database. When it comes to relational databases, although it provides consistency, it provides isolation, it is robust, it has a very simple code language, it is almost always available, consistent, etc. It has problem scaling up, right? And it will have issues when we are trying to talk about the hardware that is usually available to the relational systems. This problem usually will come when the data size grows. When the data size grows. On the other hand, we have NoSQL databases which are following the base ideology. They may have weak consistency. The last write wins. They are usually managed by programs, but they are often very simple. They represent the real world very well. However, their structure, their coding is usually complex because their structure does not contain schema. Usually, they are almost usually schema-less. That is the idea, so that we can structure them more in terms of real world. They are usually available. They are usually partition tolerant as well. They can scale out in an unlimited manner. Nothing is shared in them, hence they are parallelizable as well. Last but not the least, we understood what is the limitations of a traditional database system, which gives rise to a data warehouse, which stores variety of data for analysis purposes only, and the inherent design or the architecture of that system, of that data warehouse, will support operations at scale. Lastly, we need to remember the terminologies called data marts. We have to remember a terminology called data lake, where data lake is a dump yard of raw data until we have warehoused it by cleaning it or by putting it into a certain structure as we see fit. And the data mart is a child inside a data warehouse usually, which is created and maintained for something very specific like a department inside an organization like HR or finance. In the next videos, we will start doing a deep dive into the internals, into the structure, into the mechanisms of how BigQuery works under the hood.